Hi everybody. Got a screencast today for yet another one for the mean value theorem. We've looked at intervals. We've looked at the Rolle's theorem. I almost forgot it. We looked at Rolle's theorem, and now we're going to transition into what's called the mean value theorem, which is the most important part of these theorems. It's what gets tested always on the AP exam and always in your first year university. But it is a topic that fits very well with the regular Ontario calculus curriculum as well. So here we go. Let's get started. So what we want to do, folks, is start with Rolle's theorem. So we're going to start up here with Rolle's theorem, and we're going to take Rolle's theorem, and we're just going to take this section of what is almost a parabola, I would say, and we are going to rotate it. And so what we're going to do is take this, instead of going from here to here, these two red dots, we're going to go here to here. So we do a little bit of a rotation, and it'll look like that, right? So now the curve, we've just rotated it a little bit, it looks like that. Well, how does this relate to with what we're actually doing? Well, let's draw a secant first. So now our secant goes between x equals a and x equals b. And before, what we were doing is, down here, what we were doing is we were verifying that with Rolle's theorem, we were verifying that we would get, if the secant slope was 0, it guaranteed that there was a point on the curve where the tangent slope was 0, right? That's what Rolle's theorem says. If the secant slope is 0 and the function is differentiable and continuous, or continuous and differentiable, then there is a point, a location at x equals c between a and b where the slope is also 0. So now let's think about what we just did. So it's the exact same shaped curve, right? It's the same shaped curve. All we're doing now, though, is rotating it a bit. So now, instead of guaranteeing that the slope is 0, if the symmetry is correct, then what really I should have done here is created, and I'll just put another a line that's the same slope as that secant. So let's grab that and look. Is there a point where I get a tangent to that curve that is the same as the slope between a and b? Look at that. So this line here and this line here are parallel. So the secant slope is the same as the tangent slope here. So why do they call this the mean value theorem? The word mean, what does it mean mathematically? The average. So what do we call the slope of a secant from a to b? That's the average slope. So the mean value theorem says that if a curve is continuous and differentiable from a to b, that there's going to be a place on that curve where the tangent slope is equal to the average slope, okay, or the mean slope. And at the location, we call it x equals c. So we'll move that over there. Okay, so the location where the tangent slope is at x equals c between a and b, and where it's equal to the secant slope. So let's look at this one over here. Okay, let's look at this one over here. So what I've done is I've drawn a curve, a section of curve that's concave down, and I want to see if I take a line segment, which is the same slope as that secant. I'm going to go, so I'll start up here, and I'll get closer and closer and closer and closer and closer and closer. And then when I touch the curve, notice that that tangent has the same slope as that secant. So that location is called x equals c. Okay, and that's where the average slope from a to b is the same as the tangent slope, or the secant slope is the same as the tangent slope. So those are conditions under which the curve is smooth and differentiable. Well, what about this scenario here? What about this scenario here? In this scenario down here, we've got a couple times where it doesn't work. So look at this. One of the first things I would notice here is, and now I intended for this to be a cusp, not a corner. So what I notice here is that the slope is negative, 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 and then it would be infinitely negative, and then it would get positive, and then less and less positive. So I'm missing a whole bunch of slopes. So let's take a look at this, and as I bring this through, Is there anywhere where where it's tangent? No, and that's a cusp. That's not tangent. So there's nowhere, there's no location where the tangent slope is the same as the secant slope. Okay, that's because it is not differentiable right there. Okay, it is not differentiable there. Since it's not differentiable, the mean, like inside the interval a to b, then there's no, it's not, I can't get an average slope equal to a secant slope. Same thing here. Let's look at this one now, where I'm looking at this one here with a vertical asymptote. So I take an interval from a to b, and I get a secant slope. Is there anywhere on the curve where that secant slope matches a tangent? So I'm creating a bunch of tangents here, right? Or trying to create tangents. No, nowhere. So when I have a situation where the curve's not differentiable between A and B, there's not a chance that I'm going to get the mean value theorem just doesn't apply, right? It just doesn't apply. Okay, so now having said that, if I moved A, now this is really important. If I moved A to right here, and I created a secant now from here to here, now I would definitely, let's see if we zoom in on that, I could definitely find, let's see, so like that, ooh, look at that right there. So if I just go to the right of where it's not differentiable, so this interval here, like if I moved A over to right here and now I still have B here, the mean value theorem works. So to the right of the vertical asymptote it would work, and to the left of the vertical asymptote it works. Where it doesn't work is when I'm going across the interval. Okay, folks, so hopefully that helps. You have a conceptual understanding what the mean value theorem is. It's just what is the x value when the average slope or the secant slope between two x values is the same as the tangent slope. Okay, so we're going to set the tangent slope equal to the secant slope and solve for x, as long as we're allowed to do it. Okay, so that's conceptually, that's the mean value theorem.